Hello everyone, it's Mr. G, and today I'm bringing you lesson 7 of our Java Basics tutorial. And lesson 7 is going to be on loops. So prior to this point, anything we've done in our programs have been all sequential, which basically just means it's executing from top to bottom. There's no jumping around or anything like that. With the exception of the if statements, there's been ways that we can skip certain things, but it's all just been straight top to bottom. And now we're going to disrupt that a little bit with loops. So, loops are some of the most powerful tools at your disposal as a programmer. They'll allow you to repeat code multiple times. And this is powerful because it can save you from having to type, um, you know, many the same thing many times, or um, you can use a variable to control how many times the loop runs. So you can get the exact amount of repetition that you want without, again, having to code it because you might not know how many loop uh, repetitions you might need. So they're also good for going through collections of data, and we'll get into the first data collection in the next lesson, but let's start with the loops. So I am going to delete these imports. Yeah, no, you don't like that. And I'm gonna take everything out of there. All right, so in Java we have four loops. We have the while loop, the do while loop, the for loop, and the for each loop. And they all have their pros and cons, and we'll just get right into it. So we'll start with the while loop. And so what a while loop is it's a loop that will execute as long as whatever is in the condition is true. So let's do an example. Let's say I have an integer and we'll call it count, and we'll set that to 0. All right. So what I will type here is while. See, it turns orange, which means it's a legitimate word for Java. And we do our parentheses to set up our condition. So while count is less than 11, then I want to print line, and we'll print count. Okay. And so what this will do is we'll start it at 0, our count variable, and while count is less than 11, we'll print count. Now, you might be tempted to save this and run it, but if we do, we'll run into a problem, and I'll show you what that problem is. When you have while loops, and if you look down here, you'll see it's just outputting 0 over and over and over again very, very fast. And that's the issue with while loops. So I'm going to stop it. Um, you can have what we call an infinite loop. Because if you don't specify some kind of way to break out of the loop, because presumably it's going to be true to begin with. You want your loop to execute at least one time. And so you'll put something that's true initially in here, but if you don't have any kind of code that can allow the program to break out of the loop, then you'll have that. So what we need to do is we need to increment the or add to the count variable. So after we print out count, we need to add to it. So there's three ways that we can do this, and I'll show you all three ways. We can do count equals count plus 1. So the way that this works, assignment works in programming, is you evaluate the right side of the equal sign. So right now, count is 0. So that'll evaluate to 0 plus 1, which is 1. Now count equals that, equals 1. Okay, so we start the program with our count variable equaling 0, and then we go into this loop. While count is less than 11, then we're going to print out count, the value of count, and then we're going to add 1 to it, and then we're going to attempt the loop again. So is 0 less than 11? That is true. It is less than 11. So we print out 0. Then we add 1. And now is 1 less than 11? Yes, that's true. Print it out. Add 1 to it. Is 2 less than 11? That's true. Print it out. Add 1 to it. So we're going to do that until we're going to get to 11. And 11 is not less than 11. So at that point, it'll break out of the loop. So I'm going to run it here, and we should see 0 to 10. All right, and that's what we have. 0, 1, 2, 3, 4, 5, yeah, blah, blah, blah. All the way to 10. So now there's other ways to do this increment. This is the beginner's way. Now you can also do count plus equals 1. Okay, so what this does is it takes this value, this plus equals means just add whatever on this side of the equal sign to that, to this value. So initially it's 0, and then it takes 1, adds it to the 0, and then it saves it, and then it uses that in the loop again. So we can run that and we'll get the same output. So it's 0, 1, 2, 3, 4, 5, blah blah blah. And then there's I plus plus. Oh, not I, excuse me, count plus plus. And this basically means just add 1. That's it. You can also do count minus minus, or count minus equals 1, or count equals count minus 1. They all do the same thing. Now, a thing to note with the plus plus or minus minus, it only will do 1. It'll only increment or decrement by 1. And this is called incrementing. And if you subtract, it's called decrementing. You can only increment or decrement by 1 using plus plus or minus minus. So if you have to, if your step value is another value, if it's not, 1, then you have to use one of these two methods up here. So I'll leave that there, but we'll get the same output here. So that's a while loop. So once we get to where the value of count is 11, then we're able to break out a loop, and that ends the program. But instead of typing system.out.println 0 and then doing that 10 more times for 1 through 10, we're able to use 1, 2, 3 lines of code for, if you count the instantiation of the variable there. So that's much cleaner and less lines of code. It takes you less time. You're less likely. I mean, if you make a mistake here, you can just fix it, and it's easier to find the error. If you print out, especially if you had, what if it was 1,000? We can do 1,000, and it'll instantaneously pretty much do it. And as you can see down here, it goes from 0 to 1,000. Okay, now you can do, like I said, other amounts. So we can do count plus equals 2, or let's do 5. So we can go up by 5 every time, and we run it, and as you can see, we count by 5 all the way until we get to 1,000. All right, so that's a while loop. So basically, the main use for while loops, in my experience, is or where they're the best is when you have a loop that you want to run continuously until the user wants it to stop for some reason. So say um, you're filling up a jug and you can see when you need to stop, and the user could hit a button or something, and it tells it to stop or whatever. Playing a game and pausing it, that's stopping a game loop from running. That's just running continuously. When you pause it, you just stop the loop, and that's all it's doing. So we are going to talk about the do while loop next. So I'm going to get rid of this. We're going to keep this variable though. All right. And so the way a do while loop works is it's similar, and it makes sense once you see it in action. And it's generally good for something you want to run for a while, but you want it to run at least once. You want the loop to execute at least once. So you're going to type do, and then you're going to put your curly brace. And then what I like to do is, because I don't like to see the red line there, once outside of the curly brace, outside of the closing curly brace, you're going to put while, and then you're going to put parentheses with your condition and then a semicolon. All right. So just set the whole thing up before we start coding anything. And then I like to put the condition in. So while count is less than or equal to 10, then we're going to, and we're going to print count out. And then we cannot forget to change the value of count. All right. Same thing, not that many lines of code. And we run it and we get 0 to 10. Okay. Simple. So it's you do this stuff that's in the blocks while this condition is true. Okay. So it's pretty simple, not that much different than while loops. Don't in my experience, I've used do while loops the least of the four, but they're still pretty, neat, and they're easy to read. So yeah, it's a plus for them there. So now we'll just go to the next loop. So those were the easy loops. Now we're going to get to the loops that they're not hard, but the syntax is a little weird and it takes some getting used to. And the only way that you can really get them is to practice them. So we're going to start with the for loop. Okay. So um, the way that we do that is we don't have to set up an initial variable here. Type the word for, F-O-R, and then we put our parentheses. Now in the parentheses here, we're going to have three things separated by semicolons, not commas or anything else. So we're going to have for, let's say int count equals, let's start with 10. Okay. And then while count is greater than 0, do I want 0? Yes. Um, and then count, and we're going to do minus minus. Okay. Now usually people use a letter for this integer variable that you're going to use, and you pretty much only put integers in as this variable because you're going like 1, 2, 3, that way. You're not going to put like 0.6. I mean, you can, but let's just stick with the basics for now. So, all right. So we're just going to type system.out.print. That's not how you spell print. And then we're going to put count in the parentheses there. And that's it. We're done. We run it, and it starts at 10 and counts down to 1. All right. So now I'm going to explain it. So just going to type for, and then again, I'm going to read it to you the way I read it to you the first time. You're going to have an integer called count, and we're going to set it to 10. So that's just like when we were doing the while loop and we just had int count equals 10. Well, we're doing that there. We're setting up the initial condition first. Then, or the initial state, really. Then the condition is that we're testing is while count is greater than 0, do the code that's in the block, and then after you do the code that's in the block, do this. And this is less lines of code, it's clean, and you can never have an infinite loop, essentially. I mean, um, this ensures that you don't forget to find a way to break out of the loop. Now, I mean, you could make a mistake and do count plus plus, and you know, it's just gonna do the, you know, keep counting up, and it will be an infinite loop because it's looking for a count to drop to 0 or less, and it's never gonna do that. But I mean, I don't think anybody's gonna do that. So the for loop, and remember, we have to separate these three statements with semicolons. If you do a comma, it's not going to work. We have an error there. So semicolon it is. And you can use a variable that you've previously instantiated. So if we did int count equals 10 here, then we don't have to put anything there. Okay, because the initial condition's already set out somewhere else. So we just don't have anything, but we still can't forget the semicolon. And the condition is gonna, everything else is gonna remain the same, and it does what we need there. So um, that's for loops, and we can do another example if you need. So let's try for int, let's say students equals um, 6, and then while students is less than 100, students plus equals let's say 4. Oh, don't need that. And then just to borrow this, not count but students, bingo, and we run that. It's going to run this loop first, but we're going to start here. So it started at 6, so we set students to 6, and then while students is less than 100, then we're going to print out the value of students. So it's less than 100, well 6 is less than 100, so it prints out 6, and then it adds 4 to the variable students. So now it's 10. It prints out 10, because 10 is also less than 100, then it adds 4. So now the value of students is 14. Is 14 less than 100? Yes, it is. So it prints out 14, then adds 4 to it. And it does that over and over again. This is what a loop does. Just repeats the code that's in the loop. And then you have to, you know, you usually, you know, you'll find some way to change it so it'll give you something different. So that's for loops. For loops are pretty common, and you're probably going to use them quite a bit. So you may as well get used to them if you plan on pursuing programming. Once you get the syntax down, it's really not that bad, and it makes sense. When you read it like you would read it in English, with the exception of this initial state here, um, but you have an initial state, so students equals 6, and while students is less than 100, so there's that while word, then do the code, and then add 4 to students. And then, like I showed you in this example, you can subtract as well. You can count down. You don't only have to count up. But you use this variable to break out of the loop at some point, just in the way that you would do that in a while loop. it's just built into the loop instead of you having to code it yourself. So, and for while loops, usually the way that you break out of those a lot of the times is based on a Boolean value instead of a like another kind. But you know, it all depends on what the situation calls for. And a lot of times you can use whichever loop you want. There's no right or wrong answer. Sometimes some are better than others though, but you can't you're not necessarily going to be wrong if you use a while loop instead of a for loop. All right. So, I'm going to delete this one and I'll keep this one up just so we can see the difference because this other loop is also a type of for loop. Um, Actually, I think I'm going to have to do that kind of loop in the next lesson when we start talking about arrays. Um, yeah, because those loops are good for going through a collection of data, which is what an array is. And I haven't taught you guys that yet. So we'll stick with this for now. Now, if you go back to our last lesson, I briefly spoke about nesting. And nesting is, we nested some if statements in the last lesson. And just a small review, quick review, nesting is when you put something in something else. So, you know, an if statement inside of another one or a loop inside of another one. So you can do that here. So you can do, check this out. Let's do int x equals 0 and y equals 0. Okay, now this is something you can do. You can declare two variables at the same time, provide and give them values, provided they're the same data type on the same line. Um, so we'll do that. So we'll go while x is less than 5 or less than or equal to 5. Then we can do while y is less than or equal to, let's say, 7. Then system.out.println, and then we're going to put x, or we'll do them on separate lines. And then we'll print y. And then in this loop here, we're going to increment y. And in this loop, we're going to increment x. All right. Now let's give that, and the reason we have to do that is because these are while loops, and we have to find a way to break out of the loop. All right. So yeah, well, we can just start here. So it starts at 0. They're both 0. So it prints out 0 twice. 0 for x and 0 for y. Okay. Then it increments y 1. Now x is still 0. All right. X has not been incremented yet because we have to print out y a bunch of times. So we have x is still 0, y is 1. Okay. And x is still 0. Now y is 2 because we've gone through this loop, both of these loops again. Okay. 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. All right. Now, why did we not get more x's? We didn't print any x's. Well, because the way that we structured the loop. So if we move this, all right, we move that out and we put that there, then let's see what we get now. Let's actually just print a blank line. So it'll be or we could just delete this. How about that? All right. All right. So now we have 0, 0, right? This will probably be easier if I labeled, and don't worry about this right now. I'm going to show you how to do strings and numbers and crap later. Let's put a space. Alright, now this output is weird, okay? And this is because, so, like, let's look at it logically. So we have 0 is x and y is x. So while x is less than or equal to 5, we're going to print out x. So it's 0 right now. And y is also 0. So it's going to print out 0, and then y is 0, so it's going to print out 0. Now it's going to loop through y. It's going to complete this loop first. Okay? So when it completes, it's going to do 1, 2, 3, 4, 5, 6, 7 in the y. Okay? And that's why you see that. And then y is not um, less than or equal to 7 once it gets to 8. So it breaks out of this loop, and then it continues this loop. And so then that's when you get x1, x2, x3, x4, x5. So that's the way nesting works, and you have to be careful when you do it. Now, if you wanted to do to where it prints out x and y at each point, then you would structure the code a little bit differently. So let's empty the loops out just so you can see. Now for one, it's not going to be a one-to-one because these are different. So let's just make them one-to-one for now. All right. And the way that you would do that is I probably shouldn't have deleted them. All right, so there we go. And so it's basically what we had before, but it'll, now that we have the x's and y's, it'll show, oops, I did not increment. See, it's easy to forget to do that. So y plus plus. All right. Okay. That doesn't work because y is never reset. So y equals 0. Okay. All right. So this is what you have to type to get uh, both of them to increase in tandem. And it's not perfectly in tandem, but like not a one-to-one. I would just increment both of them in this loop for that. But that would defeat the purpose of the nested loop. But anyway, we print out the value of x and y. We add to y. Then when y is no longer equal or less than or equal to 5, it's going to break out of this inner loop, the nested loop. And then we're going to increment x and reset the value of y to 0. And with that, then now x is 1 but y is 0. So it's going to continue this loop, this like outer loop, because x is still less than or equal to 5, but it's going to start this loop again because y is less than or equal to 5. And then again, it's going to do this until this condition is no longer true. And then it's going to go back out to this loop. And then it's going to reset the value of y. So if you see, we have 0x, 0y, or x0, y0. Then we have x0, y1, x0, y2, x0, y3, 0, 4, 0, 5. And then once this is y is 5 or y is 6, then this is no longer true. 6 is no longer, or not no longer, 6 is not less than or equal to 5. 6 is greater than 5. So we break out of this inner loop, and go to the outer loop, which is the next line of code is this increment of x. So now x is 1, and then we set y to 0. Then we loop back because we're still in the loop, and then 1 is less than or equal to 5. So then we start looping y again because y is less than 5. Now if we took this out, this is what, this is an easy mistake to make. It only goes through the y loop and will never really go through the x loop. So it's just something to be careful about. But nesting can be pretty powerful, and it's better to do sometimes. So I think that pretty much does it. Am I missing anything? I mean, I can give you an example of nested for loops as well that basically are the same. So for int y equals 0, y is less than or equal to 5, y plus plus. For int x equals 0, so that we're just going to type the same exact thing except with x. Okay. All right. So it's going to print x 5 times. Then it's going to print y. Well, yeah. And but it's going to do it a little bit differently. And of course, I didn't do the labels like I should have. But yeah, let's do the labels. All right, there we go. So as you can see, 0, it does x 5 times, or 6 times really, because we start at 0, for every y, and then y 0, and then it resets. Okay, if I wanted to do what we had before, then I would do it like this. Okay, so 0 0 1 0 2 0 3 0, except the difference is now we have x as the inner loop. Before, x was the outer loop. But the nesting works the same way. But because it's a for loop, it's a little bit different because the incrementing is happening on the inside of the loop and not on the outside of the loop, um, like how we did before. So, well, the incrementing and the resetting and stuff like that, it's just in the loop like statement instead of the loop code. So that just about does it for loops. Loops can be pretty confusing, so take your time with it, practice it, watch, this video, watch other videos, a few times if, you need to, um, because you're gonna have to know it to make any kind of program that's gonna do anything valuable, make, lots of computations quickly. You need a loop for that. So this has been Mr. G, and I'll see you guys next time.